Let us see the preparation methods of carboxylic acids. The first in the list is by oxidation of primary alcohols. See, primary alcohols on oxidation by using KMnO4 in basic or KMnO4 in acidic medium gets oxidized to the corresponding carboxylic acids. So if we have CH3, CH2, CH2 propane 1-all, that oxidation by Bayer's reagent or by oxidation or by KMnO4 in acidic medium or by oxidation using chromic oxide and H2SO4 is going to give us what? Propanoic acid. So propane 1-all gets oxidized to propanoic acid. Second method of preparation of carboxylic acids is from alkyl benzene. See, let's take an example of toluene or methyl benzene. This can easily be oxidized to the carboxylic acid by using KMnO4 in acidic medium or KMnO4 in basic medium, plus we heat it, it gets oxidized to the corresponding potassium carboxylate, which on acidic hydrolysis gives benzoic acid. The most interesting thing in this is that any kind of alkyl benzene gets oxidized to the corresponding carboxylic acid, irrespective of the length of the chain, whether this alkyl group is primary or secondary, it gets oxidized to carboxylic acid. Let me give you one more example. Suppose we are having one phenyl propane, this with KMnO4 basic medium and heat, followed by acidic hydrolysis, is going to give us directly benzoic acid. So we have got benzoic acid. So this is how we can prepare aromatic carboxylic acids. The third method of preparing carboxylic acids is from nitriles and amides. Yes, cyanides can be hydrolyzed to carboxylic acid in dilute HCl like this. And similarly, any amide also, this is cyanide or nitriles. If we have any amide, it gets also hydrolyzed in acidic medium to corresponding carboxylic acid. And what is most interesting is that even if we have this cyanobenzene, this on hydrolysis with dilute HCl gives us benzoic acid and ammonia, and CH3, CH2, C double bond O NH2, propanamide on hydrolysis in acidic medium will give us propanoic acid. So this is how, what we can do is we can easily prepare acids from the cyanides or nitriles or from the amides. Fourth method is by the action of Grignard's reagent on dry ice CO2. See, Grignard's reagent we know is kind of a polar molecular species in which the alkyl chain comes out as a nucleophile. Now, every CO2 molecule's carbon is electron deficient due to more electronegative oxygen atoms. As a result, what happens is this alkyl's attack as a nucleophile takes place on this carbon of the CO2 molecule, dry ice molecule, which results in the shifting of one of the pi bonds to one of the oxygen atom. And therefore, this oxygen will attract this Mg. So what exactly we get in this is like this: R C double bond O O Mgx. So this adduct is formed, which on hydrolysis, acidic hydrolysis, gives us what? Carboxylic acid plus magnesium hydroxyhalide. Most interesting thing about this reaction is that this is very much useful reaction, especially from the conversion point of view. This not only involves the step-up process in which one carbon is increased, which is the carbon of the CO2 molecule, but also it involves what? The conversion of the alkyl halides through Grignard reagent to carboxylic acids. So it's very important for the conversion. Similarly, cyanide's hydrolysis or amide's hydrolysis is very important because we can prepare cyanides from alkyl halide by the nucleophilic substitution reaction. So that is all. These reactions are called step-up reactions and they lead to the formation of carboxylic acids very, very easily. The next method is by the hydrolysis of acyl chlorides and anhydrides. See, these are acid derivatives which can easily be hydrolyzed to the carboxylic acids. Let's take an example of the acyl chloride. Now this acyl chloride can easily be hydrolyzed in what? Basic medium, which will give us carboxylic acid and the Cl outside. Like if we have, this is called acyl chloride, and if we have this one, this is called acetyl chloride. This acetyl chloride on hydrolysis will give us acetic acid. So that's most interesting is. Another thing is this, we can use anhydrides also. Anhydrides, I think you all are knowing, are having two carboxylic groups joined to each other through a common oxygen. This on again hydrolysis, on simple hydrolysis, will give us 2 molecules of carboxylic acid. So if we are taking, this is called anhydride. So if we are having acetic anhydride, this on hydrolysis will going to give us 2 molecules of acetic acid. So this is how we can do this, the hydrolysis of these acyl chlorides and anhydrides. The next method is by hydrolysis of esters. Esters, we know in organic are called salts. In organic chemistry, so they are called organic salts because they are formed by the mixing of the carboxylic acid with alcohol. Now, these esters can be hydrolyzed both in acidic as well as in basic medium. Let's take first the acidic hydrolysis. Then what happens is this breaks down like this, So it gives us RCOOH plus R-OH. Cleavage takes place from the carbon-oxygen bond of the carbonyl carbons and oxygen bond, and the OH of the water goes with the carboxylic acid, the H of the water goes with the alcoholic part. So we get what? Carboxylic acid. and we get the alcohol back. Now, this hydrolysis is what? Reversible. It's a reversible reaction because in the presence of sulfuric acid, the carboxylic acid and the alcohol will react back to form the ester, and that is why the process which is called deesterification in the reversible reaction is esterification. Whereas if we are doing the same hydrolysis in basic medium, it leads to the formation of what? It leads to the formation of, it goes like this. So it gives us what? RCOONA plus R, if we keep it dash, R dash OH. So we get what? Sodium salt of carboxylic acid and the alcohol, and this reversibility of this reaction is not possible. We can get this back by what? By hydrolysis with acidic medium, so we can get this back plus sodium ions. So we can get the acids from this very easily. Let me give you an example to demonstrate this. Like if we have CH3, CH2, COOCH3, this on hydrolysis in what? Acidic medium is going to give us what? Propanoic acid. What you have to make out in this case, that this whole part is your carboxylic part and this alkyl group is your alcoholic part. So carboxylic part gets changed to carboxylic acid and the alcoholic part gives you what? This alcohol. Whereas we can take another example which is involving aromatic carboxylic acid also. Like we have this ester was called methyl propanoate, which has given us propanoic acid and methanol. This is called ethyl benzoate, and this on hydrolysis, like suppose we are doing it in the basic medium, what we will be getting is benzoic acid and ethanol. So this is how we can prepare acids from the different reactions.